Let's talk about system of linear equalities, graphing linear equalities, all the things linear inequalities. So in this lesson, we'll talk about linear inequalities. You're going to see that they're very similar to linear equations. They just have the inequality symbols. Inequalities meaning greater than, less than, greater than or equal to, or less than or equal to. We're going to talk about a system of linear equalities, which is also similar to like a system of linear equations, possible solutions, all of that, all the things linear inequality. So let's get into it. So what is a linear equality? It looks exactly like a linear equation. The only difference is you're going to see these inequality symbols. So every single last one of these are a linear inequality because it has the inequality symbol. Now you'll notice that some of these are in the form of like y equals, and then some of these have what we would call standard form, where the x and the y are on the same side and the constants on the other side. But every single last one of these are linear inequalities. You graph them the same way as you do in an equation. You find the solutions the same way, except there ends up being more solutions. So for linear equalities, the solution is an ordered pair. Excuse me. Is an ordered pair, but the ordered pair has to make the inequality true. So, you know, with linear equations, it was something equals something. Well, this one is going to be something's less than or equal to, or greater than or equal to. You have to make sure that the ordered pair makes the entire equation true. So let's look at this one. So 4 is a solution of this linear inequality, 3x minus 2y less than or equal to 6, because when you substitute 4 into the equation, look what happens. You end up with 3 times 4 minus 2 times 4 is less than or equal to 6. 12 minus 8 less than or equal to 6 is 4 less than or equal to 6. Yeah, so it makes that equation true. But because this is the line, you know, it goes from negative infinity to infinity. It's still a straight line when you think about it. Is that the only solution to the equation? Well, what about 3 and 4? Well, 3 times 3 is 9. 2 times 4 would be 8. 9 minus 8 is 1. Is 1 less than or equal to 6? Yes. Same thing with this one. Negative 1, negative 3. That also works. So what you're going to notice about a system of linear inequalities, it's going to have a lot of solutions. And it's probably going to take you time to say, what about this ordered pair? What about this ordered pair? What about this ordered pair? Let's just kind of go through this example. I'll end up doing some where I kind of show you the steps, but right now let me just talk you through it, and then we can walk through some. If I were to graph 3x minus 2y equals 6, this is what it would look like. I found the x-intercept point. The x-intercept is where y is equal to 0. You find the x. And then here's the y-intercept point, 0, negative 3. I set x equal to 0, and I found y. If you stick with finding the x-intercept and finding the y-intercept, all you need is 2 points. The other way is where you do a t-table and you say, okay, I pick 1 for x, what's y? I pick 0 for x, what's y? Because it's a straight line, negative infinity to infinity, you can pick any x and y you want to figure out what your ordered pairs are. I do the x-intercept and y-intercept just so I can get 2 points. 9 times out of 10 it works. If it doesn't work, you just pick different values for x and find your y, or pick different values for y and find your x. So this is what the linear equation looks like. However, if I said graph the inequality, this is what it would look like. So notice that you end up shading on the top side. That means everywhere where it's shaded, those are possible solutions for this inequality. 3x minus 2y less than or equal to 6. These are all possible solutions. So remember we said 4. Well, this is x is 4 and y is 4 is right here. Well, that's in the shaded area. Now, if you tried to pick an ordered pair on this side and you plug it into the equation, it's not going to work. So, for example, if you pick what? If we pick 3, 0, okay, where x is 3 and y is 0, 3 times 3 is 9. 9 minus 0 is not less than or equal to 6. So that's why you don't see anything shaded on this side. And that's what we call test points. But we'll get into that so you can see that. So just know that when you're working with a system of linear equations, you can have infinitely many solutions because of this inequality sign. Okay? So the line right there, that's called a boundary line. That's where you say, okay, this is where my solutions can start. If this were less than or greater than, it would be a dotted line because it means it's not equal to. But since this is less than or equal to, or if it said greater than or equal to, we graphed a solid line. This is your boundary line. And then you pick a test point, like I said, on either side to determine which side to shade on the boundary line. Very simple, very easy. So it's very similar to system of linear equations, except with this time, we're going to shade where all of our solutions are. So your boundary lines are determined by the inequality symbols, okay? You pick your test points and they let you know if you're going to shade above the line or below the line. If your inequality has one of these, it's going to be a dotted line. If it has one of these, it's going to be a solid line. 0, 0 is the perfect test point. You know why? Because everybody can multiply by 0, right? So if you pick 0, 0, it'll help you know, do I shade on this side where 0, 0 is, or do I shade on this side? Now, if 0, 0 happens to be on the line, you can't use it. You need to, because you need to know exactly which side to shade. So just pick a different test point. Look at your graph and say, I'll pick an ordered pair over here, or I'll pick an ordered pair over there. Here's this chart just real quick to kind of give you an idea. Notice that they take the equation and they put, this is slope-intercept form, where you have the y on one side, you have your slope, you have your x, and then you have what they call the y-intercept. Different lecture. So different lecture. Anyway, so if you put it in slope-intercept form where you have the y by itself, then you're able to look at it and determine which side to shade. If you leave it in standard form, it's going to be harder, but you can still figure it out. It's just going to be harder. You just can't immediately look at it. So if it's y less than or equal to mx plus b, that means you're going to shade on or below the boundary line. So depending on how your line looks, so if your line is vertical, and we'll do some top and bottom, or if it's slanted, you have left or right. So that's what that means. If it says less than, you're going to shade below, but not including the boundary line. This is where you're going to have a dotted line, okay? Y greater than or equal to mx plus b, you're going to shade above, on or above the line. Now, if your line is horizontal, above, but if it's slanted, you have to say, okay, what side is greater, what side is less than, above or below, okay? So it's kind of awkward how you look at it. And of course, if it's just greater than, then that's above, not including the boundary line. So without the equal signs, it's dotted, meaning the line's not included. With the equal signs, the line is included as a solution, okay? Now, careful. I just said this. You want to make sure you put it in slope-intercept form. If you put it in slope-intercept form, you can rely on this chart immediately. If you leave it in standard form, it's going to be a little hard to determine which side to shade on. You can still pick test points. Test points always work. That never changes. But if you decide to bypass doing test points, as long as you have it in this form, then you can say, oh, I'm going to shade on the left, shade on the right, shade top, or shade bottom. If it's in standard form is when the X and the Y are on the same side. It's going to make it, you're going to have to do a test point so that you can decide which side to shade on. If you don't do a if you don't put it in standard form and you put it in slope-intercept form, you can actually look at it and say, okay, depending on this chart, I know above or below, left, right, top, bottom. Okay, so again, system of inequalities is just like a system of linear equations. You have solutions. It's just with system of linear equalities, you have umpteen solutions because there's so many of them. Still graph them. You still find all the solutions that make it true. All of those things still work. Now, on that first example we did where we shaded it, that's called your region of possible solutions or your region of solutions. That means you can pick from anywhere on this place that we shaded. And what we're saying is that is what makes the equation true. System of inequalities, and I have to throw this plug in there. Welcome to my TED Talk, is real world math. Now, you don't say in your head, let me put my pen down. You don't say in your head, let me do a system of linear inequalities. No, that's not what you do. But it's just critical thinking. Let me show you some examples. So this one says you have $20 of snacks to spend for a movie night. Chips cost $2 a bag. Sodas cost $3 each. Well, how many bags of chips and sodas can I buy? That's a system of linear inequality because I have this amount of money to spend. This is what I want to buy. What is my looking like? What can I get? That's a system of linear inequality. Now, you're not saying, oh, let me do a system to figure it out. Your mind starts thinking. You start adding things up. That's math in the real world. So When am I ever going to use this? You use it all the time. Trust me. Look at this one. You have at most 10 hours this weekend to study and play video games. You want to spend at least 4 hours studying. System of linear inequality. You're planning a lunch that must have at least 300 calories, but no more than 600 calories. Each apple has 80 calories and each granola bar has 150 calories. That's a system of inequality. So let's look at these individually so you can see. So if I let X be the cost of chips and Y be the cost of sodas, this is what my inequality would look like. Just so I can stay within budget, I need to make sure that however many chips I have and however many sodas I buy, I got to stay under $20. And then you see these equations here at the bottom. Where'd my mouse go? Here we go. That just means you're not going to buy like negative 2 bags of chips. You're going to buy some chips and you're going to buy some sodas. You might just buy all chips. You might just buy all sodas, but you're not going to buy a negative amount of anything. So that's what that means. Look at this one. If I let S equal my study time and G equal the hours I'm going to game, this is what it might look like. The total available, I only have 10 hours this weekend. I got to study for at least 4 hours, but I also want to play games. So who's going to not play games, right? You're going to play some games. So that's what that looks like. And then this last one, which people do a lot of, counting calories. Oh my goodness. Well, how many apples can I eat? How many granolas can I eat and still get enough calories, right? I need to make sure that I get at least 300 calories, but I don't go over 600, right? And then this is the same thing. I'm going to eat some apples. I have to eat some apples. You can't eat a negative apple. That should be X greater than equals or Y. But when it does the comma, that means they're both like that. So this is real world math. This is real world math. You use it all the time. Math is critical thinking and problem solving. That's all it is. It's just when you jump into the mathematics realm, this is the name of it. Okay? So no more, when am I going to use it? You better be thinking critically, right? As I said before, when you're talking about your region of possible solutions, it's all the order pairs that make every inequality in the system true. When we had just one linear inequality, the ordered pair had to make just that one true. But now we're talking about all of them. So if you look at this particular one, 4x plus 3y is less than or equal to 24. Y is less than or equal to 4. X is greater than or equal to 0. And then y is greater than or equal to 0. So whatever ordered pairs I find, every single one of these have to be true. Now, I'm not going to work, I'm going to show you the graph of all of these just so you can see what I'm talking about. I took this, it's in standard form, and I wrote it in slope-intercept form because then I could find the x-intercept, the y-intercept, and get the 2 points that I need to graph. Can I find the x-intercept and the y-intercept here? Absolutely. Absolutely. I just get in the habit of doing it this way just to show you that both ways it can be done. Place 0 for y, solve for x. Place 0 for x, solve for y. You can still get your points. Okay? All right. So let me show you what these graphs literally, what they look like. Okay? This is the whole system. So if I graph the whole system, the y-axis, here's the x-axis. This is where y is equal to 0. This is where y is equal to 4. This is where x is equal to 0. And then this is my blue line. So my lines match the graphs. All of my graphs are solid lines because it says less than or equal to. So that means it's not going to be dotted. It's going to be on the line or wherever we shade. So if I go through all of these and we have to figure out where to shade, let's look. So let's look at the blue line first. All of the points, all of the ordered pairs that make that equation true are on the bottom side. Okay, so all of this and on the line, anything over here is not going to make blue equation true. Okay, let's go to the green line. Anything below it, see, remember when we had that chart below it, see everything below that line is less than or equal to 4. Which makes sense. So if y is 3, y is 2, now if y is equal to 6, well, that's not less than or equal to 4. That's why we didn't shade right here. Okay, let's look at the red line. Everything greater than or equal to 0. Well, x equals 0 is here. So nothing on this side is going to be shaded because these are all negative x values. But everything on this side is shaded. Makes sense? And then y is greater than or equal to 0. So this is the y is equal to 0. So it's everything above it. Now, the region of possible solutions has to be where every ordered pair makes the equation true. So if you look at these, what is the common area that's shaded? So I'm going to put my cursor right here in the middle. Watch, this area is touched by every color. So first there's blue, green, right? Red, yellow. So that's my region of possible solutions. If I pick any ordered pair in this region, it makes every single equation true. Okay, and that is your goal when you're doing that. It makes every single equation true. Every single one is true. So this is a big system of inequalities. So your goal is just graph all the boundaries. Okay, you can call these boundary lines because that's what we said. These are all boundary lines. And then you have to say, okay, where do all the boundary lines, the shaded area intersects? This is your entire solution. Now, it would take you a minute to write all these down, and that's why we use the graphs to represent that. Okay, let's graph this one. So I'm going to show you the steps that I would follow. Okay, let me turn on my piece of paper. I'll disappear just for a little bit. So these are the steps that I would go through. So here's what you do. Here's what we're graphing. Let me write it. We're graphing y is less than 5 minus 2x. It's already in slope-intercept form, so that's what we want. That's good. So now, since it says less than, it's going to be a dotted line. And I'm just walking through what I normally do in my head. And we're going to be shading below the line. Why? Because of that chart. Remember, that chart told us if it's in slope-intercept form, which this is in slope-intercept form, that we shade below the line because it says less than, sorry. So now what I normally do is I go and I find the x-intercept. Okay, that's where you find when y is equal to 0, you find x, and then the y-intercept. And this is where you set x equal to 0 and you find y. Okay, I do that just so I can always have 2 points. There's nothing different from you just plugging in some values. So when I do that, what I do is I say y equals 5 minus 2x. I just change it into an equation. After I have written them as equations, the next thing I do is I find the x-intercept and the y-intercept. So let me do the substitution. On this side here, when I'm looking for the x-intercept, I'm going to turn y to 0, and then I need to find the x. So I'm going to set y equal to 0. So I have 0 equals 5 minus 2x. Okay, now let's finish solving for x. I'm going to subtract 5 on both sides. And when I do that, I have 0 minus negative 5, right? So then that's going to be negative 5. That goes away, and then I have equal negative 2x. I'm going to divide by negative 2, divided by negative 2. A negative times a negative is positive, so I have x is equal to 5 halves. We know that's 2.5. Okay, so when y is 0, x is 5 halves. Now let's find the y-intercept. So now we're going to find the y-intercept. That's our other point. We're doing this so that we can graph the line. We know it's going to be a dotted line, and this is our line, our inequality, but we need to graph it. So on this particular side, we're going to set x equal to 0. So here, my x is 0, because I need to solve for it, right? So I end up with y equals 5 minus 0. So y equals 5. So that means when x is 0, y is 5. So this is my y-intercept. This is my x-intercept. These 2 points will help me graph the line. That's what I need. That's perfect. So, but before we do that, let's do a test point. Okay? 0, 0 is the perfect test point. So let's use 0, 0 then. Okay, so I'm going to say my test point, because I know how to draw the line. I know it's going to be a dotted line. It's going to be 0, 0. If 0, 0 makes the equation true, I'm going to shade on the side of the boundary line that includes 0, 0. So let's check. That's going to be, here's what we have. We have y is less than 5 minus 2x, but everybody's going to be 0, right? 0 less than 5 minus 2 times 0. So far, so good. 0 is less than 5 minus 0. 0 is less than 5. That is true. Okay, so since that is true, what we're going to do, shade on the side that has 0, 0. So let me show you what that looks like. Looks like that. Okay. We found our x-intercept and our y-intercept. This is just 2.5, right? We found that. And then we said, okay, it's going to be a dotted line. So we drew the line, and then you shade on this side because 0, 0 is right here. And when we plugged in 0, 0, it was true. So that's the side that we shade on. Easy, right? Graph the linear inequality. X minus 2y is greater than or equal to 3. Let's put it in slope-intercept form. Let's put it in slope-intercept form. So I'm going to take the equation and I'm going to solve for y. Okay, so I'm going to subtract the x on both sides. That goes away. I'm left with minus 2y is greater than or equal to negative x plus 3. So far, so good. Now, I'm going to divide both sides by negative 2. Now, here's something you should remember from algebra. If I divide both sides or across an inequality by a negative number, you have to flip it. Okay, if you divide across an inequality by a negative number, you have to flip it. So because I divided by negative 2, this needs to flip. Oh, sorry. I'm going to do it in red. Flip to less than or equal to. Now going to be, cancels out, right? So now this is going to be y is less than or equal to, that's a 1/2 x minus 3/2. So this is in slope-intercept form, which is what we wanted. Now we can find our x-intercepts and our y-intercepts. So this is in slope-intercept form. We know that it's going to be a solid line because it has less than or equal to. And we're going to actually shade below the line because it says less than or equal to, shade below the line. All right, let's find our x-intercept and our y-intercept. On this one, to find the x-intercept, set y equal to 0 and find x. For our y-intercept, set x equal to 0 and find y. This is to give us 2 points so that we can actually graph the line. All right. So what I'm going to do, I'm going to take this and just write it as a regular equation so that we can find it. Y equals 1/2 x minus 3/2. So on this particular side, y is going to be 0. So I have 0 equals 1/2 x minus 3/2, right? So I'm going to add on both sides. 3/2 is equal to 1/2 x. And then I'm going to divide. I know this is going to look weird to some people. And then I'm going to divide by 1/2. Divide by 1/2. Now, you're like, divide by 1/2. Yes. So let me, in my little notes over here, 3/2 divided by 1/2. That's 3/2 times 2/1. So that's 6/2, which is 3. Okay, so when you divide two fractions, you actually multiply by this reciprocal. Okay, so then we have, if I get this, we have 3, sorry, let's come down here. We have 3 is equal to x. So our x-intercept point is 3, 0. Now for the y-intercept, to find the y-intercept, we set x equal to 0 and solve for y. So we have y equals 1/2. This is going to be 0. And then minus 3/2. So y is equal to 0 minus 3/2. So y is equal to 3/2. So when x is 0, y is equal to 3/2. And we know that 3/2, that's just 1.5. Okay, so we have our x-intercept and our y-intercept. Now, we already know that we're supposed to shade below the line because of it already being in a slope-intercept form. And this tells us because it's less than, we're going to shade below the line. But if we don't remember that, that's okay. Let's pick a test point, and the perfect test point is 0, 0, 0. So let's pick a test point. The test point is going to help us determine which side to shade on the equation, right? So we have y is less than or equal to 1/2 x minus 3/2. So I'm going to substitute 0 for that. So less than or equal to 1/2, 0. So if I substitute 0, we end up with 0 is less than or equal to negative 3/2. Is that true? Nope. This is false. And because that is false, do not shade on the side where 0, 0 is. So that's why we shaded below the line. 0, 0 is up here, right here. So we shaded below the line. Through y is greater than or equal to -4. That means no matter what x is, y is always going to be greater than or equal to -4. So when you draw that, y is always going to be -4. So this is y equals -4 here. We're going to shade above this line because these are all the numbers that are greater than or equal to -4. When you do a t-table, x can be whatever number it wants to be, but y is always going to be equal to -4. We set this y equals -4 so that we can draw the line, and we knew it was going to be solid because it said greater than or equal to, and then you can shade above. Very, very, very straightforward, very simple. Let's look at this one. X is greater than 2. Same thing. It doesn't matter what y is. X is always going to be greater than 2. Now, in order to draw the line, we have to change this to x equals 2, which is this vertical line here. It's dotted because there's no equal. That means it's not on the line. It's just going to be above the line, but not touching the line. So none of the solutions are on the line. And then we shade over here because these are all the x values that are greater than 2. Y can be whatever value it wants to be, but x has to be greater than 2. Y is less than or equal to x. Another one. Y is equal to x. That means they're the same numbers. So if you just do a t-table, you end up getting the same numbers. And that's okay. Same numbers. Left, right, left, right, left, right. This is what the line looks like. We know the line is solid because it says less than or equal to. Now, we ended up shading on this side. Why? Can't plug in 0, 0 because 0, 0 exists on the line. So how about, can't do 1, 1. How about 1 and 2, where x is 1, y is 2. Is 2 less than or equal to 1? Nope. Can't shade on this side. Have to shade below it. Shade below it. See, that's how doing the test points work. 2x plus y is less than or equal to 5. And then we have x plus 2y is less than or equal to 5. We know that this is going to be a solid line because of the less than or equal to, and this is also going to be a solid line. I'm going to put these in slope-intercept form. So if I take the first equation and I write it in slope-intercept form, it's going to be y is less than or equal to negative 2x plus 5. And if I take the second equation and I put it into slope-intercept form, it's going to be y is less than or equal to negative 1/2 x plus 5 over 2. So far, so good. So now, this is our system here. Let's find the x-intercept, because we need 2 points. And our y-intercept, you only need 2 points to graph draw the graph of the lines. Okay, so this is going to be for, this will be for 2x plus y, and I'll go ahead and say equals 5. Okay, and then we'll do it for the other equation. All right, cool beans. Okay, so to find the x-intercept, we set y equal to 0 and solve for x. So we end up with, this is going to be 0, right? So then we have 2x equals 5. We're going to divide both sides by 2, and we end up with x is equal to 5/2. So when y is 0, x is 5/2. So that's 1 point. And then same thing over here to find the y-intercept. We set x equal to 0 and then solve for y, right? So that's going to be 2. The x is 0 this time. So we have 0 plus y equals 5. So we got y equals 5. That was very easy. So when x is 0, y is 5. So we have, these are our points for this line. So now let's find our points for this second line. So again, we have x plus 2y equals 5, x plus 2y equals 5. On this side, we need the y to be 0. Okay, so then we end up with x plus 0 equals 5, so x equals 5. So that's the x-intercept for that equation. And then over here, we need the x to be 0. So then we have 0 plus 2y equals 5. So 2y equals 5. And then we're going to divide both sides by 2. And we end up with y is equal to 5/2. So when x is 0, y is 5/2. These points will help us draw that graph, and then these points will help us draw that graph. So far, so good? Oh, test points. I'll show you how we did the test points so that we know which side of the graph to shade on. Let's try 0, 0. Okay, so 2x plus y is less than or equal to 5, and our green equation was x plus 2y is less than or equal to 5. So if I do 0, 0, that's going to be 2 times 0 plus 0 is less than or equal to 5. Is 0, you see that? 0, that becomes 0. So your question is 0 less than or equal to 5? It works for that. Let's see if it works for this equation over here. So then you're going to have 0. Yeah, so 0, 0. So is 0 less than or equal to 5? It checks. Shade on the side where both lines where 0, 0 is located. So if we look at this one, you'll notice that here's our x-intercept, y-intercept, x-intercept, y-intercept, the blue line, and the green line. You have all these different points that you can test. Just make sure that they work for both equations before you say this is where my solution is. So when it's one inequality, it has to work for that one inequality. But when it's a system, your solutions have to work for the entire system. 3x plus y is greater than or equal to 6. X plus 2y is greater than or equal to 7. X is greater than or equal to 0. Y is greater than or equal to 0. Okay, so if I rewrite this in slope-intercept form, it would look like y is greater than or equal to negative 3x plus 6. If I wrote this one, it's going to be y is greater than or equal to negative 1/2 x plus 7/2. These are all going to be solid lines. All are solid lines because of the greater than or equal to. Okay, so they're all going to be solid lines. Let's find the x-intercepts and y-intercepts. So 3x plus y greater than or equal to 6, the x-intercept. And then that's where x0. And then find the y-intercept. Y0, right? Okay, I'm going to use the slope-intercept form. So here we set y equal to 0. Right, and then we're going to subtract 6 on both sides. That's going to give me negative 6 equals negative 3x. Because these cancel out, 6 minus negative 6 is 0, right? And then I'm going to divide by negative 3. Negative divided by a negative is going to be positive. And so we end up with 2 equals x. Okay, so this is going to be the point 2, 0 for this graph. We're doing it for this one, okay? And then over here, set x equal to 0. Negative 3 times 0 is going to be a 0. So this is going to be 0 plus 6, which is just going to be 6. So we have this point 0, 6. Okay, so that's the x-intercept and the y-intercept for the first graph, or first line, first linear inequality. Let's do this next one. This is for x plus 2y is greater than or equal to 7. So let's find the x-intercept, which is going to be the point x0. And then let's find the y-intercept. I did the slope-intercept form up here. Down here, I'm going to do the standard form because you can see, that way you can see that it's the same thing. I don't want you to think I'm doing anything different, like in a bad way. You can still find it. It's just sometimes it requires more math to move things around, but that's okay. So on this side here, we need y to be 0. Okay. So x is going to be equal to 7. So that's 7, 0. And then over here, we need x to be equal to 0. So we have 2y equals 7, and then we're going to divide both sides by 2. So y is equal to 7/2. So this is the point 0, 7/2. Okay, so we have the x-intercept and the y-intercept for the first line, and then we have the x-intercept and the y-intercept for the second line. Now, x is greater than or equal to 0 and y is greater than or equal to 0. So x is greater than or equal to 0. That's just the vertical line. And y is greater than or equal to 0 is the horizontal line. 2, 0, 0, 6, 7, 0, 7 halves. And that's what the graph looks like. It has to make every equation true. Well, you kind of have an idea of what test points you can't pick. This kind of limits you. So you want to pick where x is greater than or equal to 0 and y is greater than or equal to 0. So if you pick test point 0, 0, it's false. It doesn't work for all the equations. So I'm going to put does not work for everybody. 3, 1. And I'm looking at the graph. 3, 1, if you plug in 3, 1, it doesn't work for everybody. 0, 5 also doesn't work for everybody. And with the test points, you're taking these test points and you're substituting them into every equation that's in the system. Take every test point and plug them in each, and every equation has to be true for every equation. As you can see on this one, it does not work for this one. So if I choose 0, 0, doesn't work. 3, 1 doesn't work. 0, 5 doesn't work. And so we shade. So the y, it has to be greater than or equal to 0, has to be greater than 0 here. And then this line, it has to be above this line. So it can't be below the line, right? Because it says all of these were greater than or equal to. And then it has to be above this line. So as you can see, it's above every line that it's supposed to be above. And this is the entire solution for the entire system. Okay, some common mistakes when doing a system of linear inequalities is not paying attention. Really, just not paying attention. Consider using slope-intercept form. It'll help you graph it. Some people don't consider it and they find it a little harder to graph. But if it's in standard form, you can still pick points and graph those points. Pay attention to the inequality symbols. Okay, that's going to tell you solid line, dotted line, which side to shade. Don't forget, if you multiply or divide across an inequality symbol by a negative number, you have to flip it. Multiply or divide across. If you divide both sides by -2, if you multiply both sides by -5, you have to flip the inequality symbol and then pick proper test points. Make sure that you're seeing the test points. You're looking at your graph and you're going to say, does this point make every inequality true if it's a system? If it does, that point should be included where you shade. And then don't be afraid to use online graphing calculator. The reason why I showed you the steps of finding the x-intercept and the y-intercept is because I know not everybody can use a graphing calculator or an online graphing calculator. But if you can, I recommend the Desmos graphing calculator. The same way you see the inequalities, you can type it in there the same way and draw your graph. I'll do a video on how to use Desmos because I really like it. And then, of course, check behind yourself. Okay. Key takeaways. Make sure you place the inequalities into slope-intercept form. It's going to help you with graphing and then seeing immediately what side of the boundary line that you're going to shade on. Again, it's not a must-do, but it does help. Take your time. What side do I need to shade on? Especially if you don't do the slope-intercept form. Pay attention to the inequality symbols so that you know if your line is going to be solid, dotted or solid. And then double check your work, especially when there's negative. If you divide both sides of the equation by a negative number or multiply and you go across that inequality symbol, you have to flip it. Okay, cool beans? Now, you should be able to complete your assignments with success. Follow the steps that we've done in this video. If you have questions, don't be afraid to reach out. I'm always happy here to help. Some questions may be harder than the ones that we did here. That's okay. Follow the same steps. It should work exactly the same. And always reach out when you have questions because I am here to help.